to thank you for joining us on today's webinar on web application and network penetration testing for PCI 3.0. The focus of today's webinar is really to discuss the impacts of the new DSS requirements on both web application and network penetration testing, so that you understand the impacts of that as you prepare for your 3.0 assessments. We're also going to provide some insight on the common issues that we discover performing these types of tests for our clients, as well as the success factors that we recommend in order to ensure that you can pass your penetration tests. And then we'll wrap up with some Q&A, and I'd like to remind you that you can post questions through the chat feature here on Citrix, and we'll be able to respond to those at the end of the presentation. So, just to summarize, the real intention of this is we want to really empower you guys to be able to pass your PCI penetration test requirements for 3.0 and not have any surprises. So we'll start with some brief introductions here. My name's Adam Gadosh. I'm the Director of Professional Services here at Anitian. I've been a QSA for over 5 years, performed an extensive number of audits, both on the merchant and service provider side, wide range of industry verticals and different types of environments. And I have a fair amount of experience beyond the audit world on pen testing and forensics as well. James, introduce yourself, please.
Yeah, hi everyone. My name is James Buchelman. I'm a senior security analyst and pen tester here at Anitian. I had about a 15-year IT career, background in systems and networking. About the last 5 years or so, I've done a lot of security compliance engineering for actually not just PCI, but also NERC-CIP. So.
Okay, and James is our lead penetration tester now, so he'll be providing some of his insights on the common things that he finds and some tips there to prepare for your assessment. So, just a little background about Anitian. Our really goal here is to provide business intelligence to leaders. So, we really look at all of our engagements as a way to empower you guys to be successful in enabling you to succeed by using a pragmatic approach to security. And that's really what our ethos is all about. So let's get right to it here and talk about the new testing requirements in the 3.0 version of the PCI-DSS, which is the data security standard. So the new version was published in November of 2013. It is currently live in that you can have your assessment this year be performed against the 3.0 version, although in most cases we find our clients are opting to assess against version 2.0, which the Standards Council allows you to do through the end of this year. So through the end of this year you have the optionality if you would like to audit against 2.0 or 3.0. Starting next year you have to perform your audit against version 3.0. Additionally, there are some net new requirements in the 3.0 version of the DSS, including some of the ones we're going to talk about today that are specific to web app and network pen testing. And within the standard, you'll note that for these new requirements, there is text that cites that those requirements are a recommendation until July 1st of 2015, and then after that, they are a requirement. So there's a little bit of a grace period there that if you are performing your 3.0 assessment next year prior to July 1, 2015, then you are not beholden to the net new requirements, although they are recommended, and the intent is everyone should have had enough time to prepare for them, and from our analysis of them, they're really not that significant that they shouldn't be an issue for people to prepare for in the event that they are having their 3.0 assessment in the first half of the year. But the fact is they are an option until July 1st. The PCI-SSC, which is the Security Standards Council, which is responsible for all the various PCI standards, they have a document on their website. It's called Summary of Changes from 2.0 to 3.0. It's got a lot of minute details. It's written from a bit of a tech writer's perspective, but it does call out the net new requirements in addition to all the other extraneous detail in a table format, and it notes them as evolving requirements. So there's a little key at the beginning of that document, but you can use that as a reference to see which ones are the new requirements. And you could also simply just do a search within the DSS to see for 2015, and basically anything that has that italicized text will call out a new requirement that's not required to be met until July 1st. So let's talk about, there's 3 new security testing requirements from a high level here. There's one new item in the web application testing requirements that is in requirement 6.5. 6.5 has a bunch of sub-requirements. These are categories of vulnerabilities, and they've added a new one. Then additionally, under requirement 11.3, which is network penetration testing, there's 2 new requirements there. One concerns having a documented formal penetration testing methodology, and the other piece is having the penetration test validate the effectiveness of any implemented segmentation of the cardholder data environment. So we'll start with the web application security testing requirement, the new one here. So as you can see, we're showing all 10 of the vulnerabilities that are required by requirement 6.5 to test for. 1 through 9 are not new. Those are legacy requirements. The new one, though, is 6.5.10, broken authentication and session management. So before we drill down on that, just to provide a little context on these vulnerabilities that are required by 6.5 to test, it's important to note that in most cases, these are classes of vulnerabilities or categories. These are not necessarily specific vulnerability types. Injection flaws. There's more than one type of injection. Even cross-site scripted. You could have reflected cross-site scripted. There's different categories of these. So it's important that the personnel at your organization, they're responsible for performing the security code reviews as part of your secure software development lifecycle, are able to understand which of specific vulnerabilities that might be discovered during that review actually map to these categories in 6.5.1 through 6.5.10. Your QSA could provide guidance on that as well. So we'll start here with 6.5.10, the new one, and drill down on this one a little more.
Awesome. So broken authentication and session management. Securing authentication, that topic could actually be a webinar all on its own, so I'm not going to go into a huge amount of detail on that. One of the things that I do see frequently is usernames and or passwords in cookies. Don't do that. We're going to talk a little bit more about session tokens in a few seconds here. But the session token is really the only thing that needs to be passed between the client and the server. A couple of weeks ago, I was doing a web app pen test and noticed a strange base64 encoded information in this cookie, and lo and behold, it was actually the username and password in that cookie. And of course, we all know that base64 is an encoding mechanism, not an encryption mechanism. It was basically the same as plain text. So don't do that. Username leakage. Now, this is something I see probably 25 to 35% of the time. And it's something that a lot of people don't necessarily think about when they're designing a web application. When you log into a website or to a secure area, if If you enter invalid credentials, that application should just give a generic message, login failed. It should not explicitly tell you if the username was good or not. We actually have a case study on this, and we'll talk about that here in a second. But if an error message states that the username is incorrect, then an attacker can harvest a list of usernames, and now he's 50% of the way to obtaining the complete credential. He can then use those usernames and brute force passwords and eventually gain access to your system. So you certainly want to keep in mind you want to try and maintain the confidentiality of usernames as well as passwords. Securing sessions. So everybody knows what authentication is. What is a session? Well, traditionally, an HTTP client will open a connection to a server, download the web page, and then close that connection. And once that connection is closed, the server completely forgets about the client, has no idea who it is. When that client makes another request, the server treats that request as if it was brand new, from a brand new client. So a session allows the server to remember that client across requests. HTTP is, typically not what we call a stateful protocol, and a session allows us to maintain a state, basically, across the user experience of the application. The sessions are created and maintained with what's called a session token, and the session token is a random string of 15 or 20 random characters.
Hopefully random.
Hopefully random. The server assigns the session token to the client, and every time the client makes a request to the server, it passes that session token along with the request. The server looks at that token, matches it up, says, oh yeah, I know who you are, displays the page. There are a number of attacks that a hacker can use if he obtains that session token. So we need to try and maintain the confidentiality of that session token. The best way to do that is in a secured cookie. And by secured, I mean we're going to set two different flags. On that cookie, we're going to set the HTTP only flag, and that means that only the HTML realm can access that cookie. It will prevent JavaScript from reading it. Secondly, we're also going to set the secured flag, which means that cookie will only be transmitted over an encrypted SSL connection. Just about the worst place you could put it is in the URL. It's common. I've actually seen this. But the URL, of course, as you know, is not encrypted, and it is trivial to obtain the session token and attempt to log in as a user that holds that token. Build in appropriate timeouts. And what is an appropriate timeout? Really, that's going to depend on your business requirements. Is this application publicly accessible, or is it internal only? What kind of data is on there? It's really a very subjective answer, and I can't really give you the best answer, but try and make it as short as possible, for sure. Rotate the session ID. Now this is something that almost nobody does, and here's the reason for it. A session token is usually assigned to a client as soon as they hit the website, before they log in. And that means that session token was transmitted in clear text, oftentimes transmitted in clear text and not encrypted. And at that point, an attacker can obtain that session token. When the user logs in, hopefully over an SSL encrypted connection, that token is exchanged encrypted. However, because it was exchanged in clear text, it should be changed once they log in. And that way we ensure that the token that was transmitted in clear text has been expired and is no longer valid, and the only one that is valid is only being transmitted over the encrypted line. So yeah,
and applications handle this in different manners, but a good example is if you've shopped at Amazon and if you go to checkout, even if you are logged in, it will prompt you again for your password. So there's just these little roadblocks to keep things from being, you want to maintain state, as you noted there, James, but keep things rotating as you either go to the secure side of the site or escalating privileges, not necessarily user privileges, but in that case, it's the action you're about to perform. So, so I guess we could talk a little bit about a recent incident that we were involved with that was, not a particularly sophisticated attack, but it does show how these issues could be somewhat subtle. I mean, one thing that we are trying to communicate that these categories of issues under broken authentication and session management are pretty broad. We've cited a few common examples of specific vulnerabilities that we see. The insecure cookies, for example, I bet we see that on 80% of the web app tests that we perform. But there's a wide range of things here. And so the username harvesting, as James mentioned, is something that is sometimes overlooked. This most commonly applies to, the login page or perhaps the forgot password function of the application if it supports that. And so in this particular case, though, it was on the login page, and it was a very specific instance of username harvesting that had been overlooked. The application had actually implemented a non-specific failed login message that was returned regardless of if you had an incorrect username or password. And so that was good. If you logged in with the right username, the wrong password, or a wrong username, you couldn't tell the difference. Except for one very specific case where certain users of this public-facing application, certain super users at the company had two accounts, basically. And so both accounts were tied to the same username, which was their email address. And so for some of the employees at that company, if they logged in with their email address and the wrong password, it would fail and not say, oh, you have the right username. But if you logged in with the email address of one of the employees that had this kind of super user privilege, if you will, even if you had the wrong password, it would pop up and say, oh, which of the two accounts are you trying to authenticate against? And so it was a very small subset of their users, but they were the most privileged ones. And so the attacker discovered this, and because the issue was amplified because the username was, in fact, the email address of the employees, which followed a pretty standard format of, first name, last name, or something along those lines. They were able to then go on LinkedIn, harvest a bunch of employee names, seed their username list, and do an automated attack on the login page to harvest all the valid usernames that had this super user privilege. And then from there, it was a matter of just performing some brute forcing on the passwords of those now known validated super user accounts. And of course, the classic situation, they had a test super user account that they had enabled at some point with a really trivial password. And that was all it took for the attacker to be able to compromise the application via a username leakage issue. So it was a little bit on the unusual side in the fact that the organization had handled the failed logins properly for almost every class of user. Unfortunately, the one class they omitted to do that for was the most highly privileged user type within the application. So it's just a good example of, when you're performing your testing, to really make sure you have a full understanding of the application surface area, not only when you're performing the internal testing of the application, which is required by requirement 6.5, but also when you're performing the external testing performed by third party. The requirement 6.5 issues are types of vulnerabilities that are required to be tested. They're required to be tested twice, though. They're required to be tested internally as part of your secure SDLC, but they're also required to be tested externally by requirement 6.6 for the production-facing applications. So as entities that are performing your own assessments during your SDLC, it's really important that you really have a good handle when you're performing this internal security analysis of all of the different conditions and user account types and ways that authentication and session management is handled within the application, and those are all explored because it's easy to overlook the one-off situations, and in this particular case that was all it took. So let's move on here. Let's talk a little bit about the network penetration testing requirements that are new to the 3.0 version of the DSS. So the first one is actually the top-level penetration testing requirement itself, which is requirement 11.3, and it requires that you have a formally defined penetration testing methodology. And there's some specific criteria, which we'll talk about here on the next slide, that you need to meet within your defined methodology. And those are the criteria under which the penetration test is conducted. And the point of this is to ensure that your penetration test is legitimate, that the audit artifact that you are providing to the QSA attest to that fact, so that the QSA can determine that this was a penetration test that was conducted to industry best practices. As a QSA myself, I have seen penetration test reports where it was clear this was nothing more than some type of automated scan. Going to the community meeting that the council has for auditors and other people involved in the PCI world, it's very common for there to be a misunderstanding between the difference between a vulnerability scan and a penetration test, and exactly what their expectations are. And so you'll notice much of the clarification within version 3 of the DSS is to make the intent a little bit more explicit. People have often complained that the DSS is a bit vague in some places, and so they tried to tighten that up a little bit more and make it very clear what their expectations are. And so that's what they were doing with this requirement. There's some specific things that they are stating your methodology must follow so that you are getting a penetration test, not just some automated scan, a quick checkbox, here's an automated report. The expectation is that there is manual analysis, that there's research that is performed, that the coverage is broad, appropriately scoped, some other things we'll talk about here in a moment. But having your own defined penetration testing methodology and requirements for it, again, not only does it provide a valid audit artifact to your QSA, but it's also something that you can use as a company to screen potential penetration testing firms, because they are going to have to be ultimately performing the penetration test on your behalf using a robust methodology. And so it's a good way to screen the legitimacy of what exactly the service they're offering is, so you can make sure it aligns with the DSS. So the other requirement is the CDE segmentation verification. So this is a sub-requirement of the pen test requirement, which is 11.3. And so this 11.3.4 is a net new requirement where they are requiring, as part of the pen test, a technical validation of all segmentation technologies. So what we're talking about here is that while not required, it's highly recommended, and almost everyone that I've audited, and certainly anyone who's had a successful assessment, has implemented some level of segmentation between their cardholder data environment and the rest of the systems in their environment, to shrink the scope of their assessment environment. And so you're implementing some type of segmentation technology, most commonly firewall access control lists, to segment off the systems that touch cardholder data from those that do not, essentially making the LAN be untrusted. And the idea here is that you need to, as part of your pen test, have the pen tester validate that whatever you implemented to segment your CDE systems is effective. So we could drill down a little bit more here now on the penetration testing methodology. I know this slide is really dense, and I apologize for that, but this is verbatim from the DSS version 3.0, and I thought it would be good to capture here, especially in the webinar format where this is not on a projector up on stage where you're all squinting in the audience here. But some of these are pretty important, so I'd like to talk through them just to make sure everyone understands really the intent behind this language. So the first one is fairly broad, but it's probably arguably the most important. Based on industry-accepted penetration testing approaches, they cite one of the NIST special pubs, which is a great baseline. It doesn't have to follow that verbatim. But what they're really meaning here, what the intent of this is that this is a legitimate penetration test performed by people that have the expertise and the experience to execute a penetration test in accordance with what the most recent industry best practices are. This does not mean someone comes in and kicks off an Nmap scan and calls it a day. It means they're using whatever the tools that are appropriate for your specific environment, that they're doing the analysis, the research, the recon. In most cases, they're using probably a wider range of tools. Of course, there's going to be some baseline automated information gathering that occurs. We do that ourselves. We have some tools that we use for almost every penetration test to provide some basic information, but you've got to take it a step further. That's what industry best practices are, and that's what they are trying to convey here. And so this is a very important requirement, and it's also important because this is the requirement that becomes a shared responsibility with not only the assessed entity, e.g. the merchant that is actually, or service provider, that's having their penetration testing performed. They have to require this as part of their methodology, but then the third party that is performing the pen test on their behalf, they have to implement a methodology that aligns with this requirement. So this is a shared responsibility, and that, of course, implements some audit risk in and of itself, which is why, again, it's important to screen your vendors appropriately and make sure that your requirements are explicitly clear. So the other ones here that are required by this requirement in your new methodology are a little bit more specific. The coverage includes the entire CDE perimeter and all critical systems. Okay, so that means that you are not just doing a loose sampling, that your scope is appropriate for what the test is. Testing is performed from both inside and outside the network. The other sub-requirements of 11.3, which are not new, and so they're not noted here, there are both internal and external penetration testing that are required. External penetration testing, this is commonly just performed over the internet of your internet-facing systems, but internal penetration testing, this means you're inside the CDE, in the trusted network, inside whatever those segmentation technologies are, inside the firewall, inside the ACLs. The idea here is that you're not testing the perimeter security technologies for that phase of the penetration test, but you're actually testing the security posture of the systems in the CDE themselves. So, for the external penetration testing, if you have a robust network perimeter with firewall and IPS and other augmenting technologies, you might be able to get away with having fairly insecurely configured servers behind it. But that's not what is expected of PCI, and so the internal testing would reveal that you might have a service with a default password listening on a system internally, as an example. So that's testing from both inside and outside the network. We've got testing to validate any segmentation and scope reduction controls. Again, this is the new requirement, and there's more detail that we're going to talk about in a moment, but it's got to be in your methodology as well. So this is basically a bullet point of essentially policy requirements that you need to have in your methodology. You know, our penetration test must include these items here. That your methodology has application layer penetration tests, include at a minimum the vulnerabilities listed in requirement 6.5. What is this talking about? It's talking about web application interfaces within your CDE. We see this quite commonly. There could be some management interface for a technology in the CDE that has some type of vulnerability. Most commonly, it's the default password. You worry about hardening your systems, but then you install some application that has a web management interface, and you're using the default password there as a very trivial example. So that needs to be included as part of your testing. Network layer penetration tests, of course. So this is at the network level, the OS level. I mean, effectively, we're talking about all 7 OSI layers here. And they just want to make that explicitly clear. Includes review and consideration of threats and vulnerabilities experienced in the last 12 months. There's a theme throughout 3.0 where they're trying to emphasize the responsibility for entities to maintain compliance and maintain threat intelligence and understand what threat exposure they have, understand how the landscape is evolving so they could respond to it appropriately. And this underscores that here, specifically to those that might be specific to the entity, either as a real situation that they've had or a known threat scenario. So, and then the last piece is that you have to retain your penetration testing results and remediation activities. Part of this requirement is that if there are findings, you need to remediate them and have the penetration test reperformed to validate their effectiveness. And you need to retain the documentation on all that. So, you know, really the crux of what this is trying to say is that you need to have a real legitimate pen test, not some cheap little automated scan where someone's going through the motions and providing you no value and leaving you in a situation where you feel great about the fact that you had someone go through the motions, yet you still have a high level of threat exposure. You know, it's almost the target requirement here, right? That was a bit of a black eye for PCI. They need to avoid that happening in the future, and cranking down on what is required as far as the robustness of the penetration testing is a good place to start. So, you know, and when you look at reports too, it's also important to consider what the report looks like. This is the audit artifact to your QSA. And if the audit artifact you're providing is some type of automated vulnerability scan report, then that's a problem. I would immediately question whether or not this was a real penetration test performed. That certainly could be provided as some type of supporting documentation for the pen test, but that's really the key here, is that a full-blown legitimate pen test is performed, and that's what this methodology section is all about. So let's move on. The next piece here is the CDE segmentation verification. This is a net new requirement, and it's really important because as a QSA, I would say one of the most common issues I find is segmentation and scoping is incorrectly implemented. It's very commonly misunderstood, and if your scope is not properly defined and your segmentation is not going to be properly implemented, then you are pretty much doomed from the start. I don't want to go into too much detail on how to effectively scope a PCI assessment. It's a little bit beyond this particular webinar, but from a very high level, you have to start with what's your cardholder data environment, and that is any system which stores, processes, or transmits cardholder data. So basically, if it touches a payment card, it's in the CDE. Anything else in that same network that's not segmented by some technology such as firewall ACLs are also in the CDE. So basically, in a nutshell, you map out your cardholder data flows and say, okay, these are all the systems that have to touch cardholder data. Now, how could we isolate these with ACLs so that only those systems are in the CDE? So that's what you would want to do. A simplistic example might be a web server with an app tier, 3-tier web app for e-commerce. And you might have a DMZ where the e-commerce web server sits, and then there's a bunch of other DMZ servers that are providing other functions for the entity. You'll want to segment those, so you just set up a separate DMZ for the new web server. Now it's dedicated. That subnet there is your CDE DMZ. And then you would do the same for the back-end systems as well. So now that you've isolated your CDE systems, you'd say, hey, what's the assessment scope? The assessment scope is any system which either has connectivity to the cardholder data environment or provides some critical function. So as a QSA, I simply say, okay, you've showed me your cardholder data flows. You've showed me how you've isolated all those CDE systems into these dedicated subnets behind access control lists. However, they don't need to be air-gapped. They are allowed to talk to other systems in your environment. However, by virtue of crossing that trust boundary, the systems that are allowed to connect to CDE systems through your segmentation technology are now in the assessment scope. And so at a very high level, that is what scoping and segmentation is all about. So this, again, is a common problem, and of course it can be misunderstood and implemented incorrectly. But even if the intent is correct, the fact of the matter is, because everything that's not in the CDE is considered to be untrusted, if there is some type of break in that segmentation boundary, then you've got a leak in the dam. And that's really what they're trying to make sure that is tested technically. And of course, as part of the assessment process, your QSA is going to be validating your segmentation. They're going to be looking at the configuration of all of your firewalls or routers or whatever other segmentation technologies you have. But this is taking it one step further. Actually have a legitimate pen tester following industry best practices test those boundaries and make sure that the CDE systems are isolated appropriately. In italics there, that's part of the standard. That verifies segmentation methods are operational and effective to isolate out-of-scope from in-scope systems. So, provide tester documentation of segmentation technologies. So this is something that has always been required by the standard. However, it has not been as explicit as it is in 3.0. It is the responsibility of the assessed entity to define their assessment scope, define how they've implemented segmentation, what their data flows look like, what their cardholder data environment is. And this is all called out in explicit detail in, I believe, page 10 of the 3.0 version of the DSS. So prior to the actual table of requirements in the data security standard, there is text talking about the scope of PCI, and it has a bullet point list of explicit things that the assessed entity must do to define their environment and be able to provide that to their assessor prior to the assessment and maintain that documentation as things might change throughout the year. And so that needs to be provided to the tester so that they understand what the appropriate scope of the pen test is, so that when they rate up their report and provide it to the QSA, everything matches. And that's where things sometimes fall apart as a QSA, where I look at the pen test report, and even if it was a legitimate pen test and not just some ding-dong scan, the scope might have been incorrect because the entity did not provide the tester the appropriate scope. So, that's something that you need to make sure that you're on top of course. The testing against CDE systems from the outside of the CDE, again, you're going to have a target list of systems in the cardholder data environment that from the LAN, an untrusted system should not be able to access those systems. So, James, you would have your laptop on the LAN, you would grab a DHCP lease, and you would say, okay, I know these are all the in-scope systems within the CDE. I'm an untrusted system. Can I access them? And so, he would do some scanning, some probing of the firewall, look for ways that he could try to bypass the segmentation technology to ensure that moat is fully encapsulated in the CDE. And then conversely, you need to test the other way around too. CDE systems need to have robust egress ACLs as well. So they can't just talk to anything outbound. It needs to be tight. So within the CDE, you need to make sure that the segmentation there is also appropriate outbound. So that's really the crux of the CDE segmentation issue. So let's talk a little bit about how to pass a penetration test here, because that's really what this is all about. We've talked about what the changes are within 3.0, but now we'd like to provide a little insight into what you really need to do to prepare to pass a penetration test. And some of these things are not specific to 3.0. These are just based on our experience, James as a pen tester, myself as a former pen tester and a QSA now, primarily. What we see as common issues. So we'll start with common network vulnerabilities. James, you want to talk about these a little bit, please?
Yeah, absolutely. So the things we're going to discuss are the things that we see most out in the field. Default credentials, you probably hear this a million times, but it's the year 2014 and I still see default credentials all the time. I recently was pen testing inside a customer's CDE, and I found a Linux box that had default root credentials. First thing I did, I went right for the low-hanging fruit, logged in, realized that it was their network management database.
Oh, that's convenient.
Right? So I dumped the database, and now I have every single username and password and config for every Cisco network device in their enterprise. It took me about 10 minutes. So change those passwords. Security patches. If you are missing security patches, rooting your box can be as easy as pushing a button in Metasploit. It should never be that easy. Patch, patch, patch. Third-party applications. Patching does not just apply to operating systems. Also applies to applications such as Java, Apache, and practically anything made by Adobe. I see a lot of certificate issues as well. The problem with self-signed certificates is that when a user sees the security warning, we're training them to bypass that security warning and to just click OK on it. Really, we need trusted certs from either an internal CA or purchased from a trusted external CA. And we should be training our users that if they do see that certificate error message, that's a problem. And they should be reporting that.
And I'd just like to add, we tossed this one in here. This is really not a pen test failure vulnerability because you're not going to use it to remotely compromise a system, but it's probably the most common issue that I see as a QSA on why an external vulnerability scan by an ASV fails is because there's some type of internet-facing self-signed cert. But the weak ciphers and old protocols certainly could be a failure issue, right, James? If you're able to actually capture data that's not secured correctly through some man-in-the-middle attack and then gain credentials that way, of course.
Absolutely. There are exploits that will force encryption negotiation down to the lowest common denominator instead of the highest. And, of course, you've got man-in-the-middle attacks and whatnot. Windows, SMB signing, again, this is kind of in the same category, but there are some reg hacks you can do to secure the SMB messages in Windows domain networks. Null sessions are actually some of my favorite. Oftentimes, using a null session, I can enumerate the enterprise password policy. So now I know exactly what to set my password brute force tools to. If I know that your password has to be 8 characters long and has to have at least 2 numbers, that can drastically reduce the time it takes to brute force a credential.
And usually when you see that, you'll also see that user lists could be enumerated from a domain controller. So now you have all the usernames
Absolutely.
and the password policy.
Absolutely. Even if you've changed the username of the administrator account, which they oftentimes recommend that you do, I can enumerate it with a null session. So continuing on from the last slide, again, this is the year 2014. I still see lots of telnet. Disable it, get rid of it. SSH is the only way to go.
It's got to be encrypted in transit, period.
Got to be encrypted in transit. There's just no substitute for it.
If we can implement a simple ARP cache poisoning attack and capture credentials in a man-in-the-middle, then it's it. It's game over. So not allowed. It's explicitly prohibited by PCI, and it's a common thing that we see.
Yep. Same with FTP. There's multiple options. SSH version 1 was compromised, I don't know, 10 years ago or more. It's not considered secure, so everything should be at SSH version 2. Oftentimes on Apple systems such as iMacs and whatnot, I run across the virtual network computing, the VNC. It is free and open source, and the free ones usually have weak or no encryption or security mechanisms built in. Again, that's an unencrypted management protocol, and that needs to be encrypted. The commercial versions, I do believe, possess stronger encryption and security technologies built in. I gave Heartbleed kind of its own little bullet point here. I do see a lot of Heartbleed vulnerabilities. There are tools out now which they're little GUI interactive tools. You just fire it up, give it a URL, click OK, and it will dump all the memory for you. It's an extremely trivial attack and can be potentially devastating. Inside that memory can sometimes be the private key for your encryption. And if an attacker obtains that, you no longer have encryption.
Yeah, SSLs now, you can decrypt everything.
It's been completely defeated.
Of course, usernames and passwords and such. Ineffective and inappropriate scoping, we already talked about that to some degree. And so in the interest of time, so we have time for Q&A, I'd like to move on past that one. But, just in a nutshell here, these are some of the common things. It's password management, it's host hardening, patch management, transit encryption issues. So let's quickly run through some of these common web application vulnerabilities, James.
Yeah, definitely. OWASP, the Open Web Application Security Project, they release a top 10 list of vulnerabilities. Most recent one was updated last year. So I'm not going to cover all 10 of them, but I just kind of picked the top 5 here that we see frequently. Injection and broken authentication, just kind of go through these here. Injection is actually a family of attack types. SQL injection being the primary attack method. This happens when the contents of a variable is inserted or is utilized directly into a SQL query. And I can manipulate a SQL query and have it dump the contents of a database. So anything inside that SQL database is potentially vulnerable to a SQL injection attack. Usernames, passwords, credit cards. If it's healthcare, it could be health records. So that's why the SQL injection is such a dangerous attack.
Yeah, it's the worst case scenario. You're providing an
Very worst case
access to all your data.
Access to all your data, absolutely. There's a simple test you can do. This is not a comprehensive test, but it'll give you somewhat of an idea. Just send an apostrophe in the form field, and depending on the output that you get, that should kind of give you a clue. Sanitize all your input, not just the user input, but all of the input, even the system variables that maybe are created just for internal use. Command injection. So this happens when the contents of a variable is passed to a operating system executable. So, for instance, if I type in format C:, and you pass it to cmd.exe, I just formatted your hard drive, you're going to have a really bad day.
It's an unusual one to find, but the fact is it's catastrophic.
It is catastrophic, and I do see it on occasion, not nearly as frequently as SQL injection, but I do see that.
LDAP's another one in that category, but much less common. All right.
Yep. Secure authentication and session management is actually number 2 on the OWASP top 10, and I threw this slide in here just to kind of make a point. Many of the PCI requirements map directly, and in some cases verbatim, to the OWASP top 10. So if you're not familiar with the OWASP top 10, it's some excellent material.
Open Web Application Security Project. It's a great reference for how to discover these vulnerabilities, how to prevent them, how to fix them. So it's a great resource for secure development.
Cross-site scripting. Again, this is when the contents of a variable is basically inserted into JavaScript, and then that would execute on the client's browser. Like, you can potentially dump the contents of cookies and whatnot. Again, it sounds a little redundant. Sanitize all your inputs. Sanitize, escape characters, HTML code, I think is the term I'm looking for here.
And this is the most common one by far. And it's very binary. There's no false positives. If we submit a request with some JavaScript embedded, and that's echoed back to us, then that's it. It's cross-site scripting. It's that clear. So,
third-party components. The entire security of your server or your systems could be dependent on a plugin that you install. WordPress is famously insecure, and some of the plugins that they have for that are also notoriously insecure. If that WordPress has a plugin that has remote code execution, I could essentially own your box because of that plugin. So just be cautious.
Just because you didn't write the code for the component you're using in your web application doesn't mean you're not responsible for its lack of security.
Exactly.
And it's why a legitimate web app test should be using the tools that are appropriate for the environment. We have primary tools we use, but WordPress specifically, there's some specific WordPress testing tools that we'll use that might be missed by some of the more basic web proxy-based testing tools.
Yeah. So now you're betting the security of your site on some unknown developer that you have no business or personal relationship.
Yeah, hobbyist, basically.
Hobbyist. Yeah.
Right.
Unvalidated redirect and forward. Yeah. I have actually seen this one, and this happens when the contents, when the browser will redirect based on the contents of a variable. And this is kind of a trivial, oversimplistic example that I have here in the slide. But this absolutely does work, and I've done this actually to a client, of course, and took all the evidence of whatnot, but it works. It's easy to hide what you're doing, and the results can be particularly devastating.
Because, of course, he can encode that URL string.
Exactly.
And so this could be executed a few ways. Phishing attacks, if there's a cross-site scripting vulnerability, it could leverage something like this. This is like your classic clickjacking here. So let's talk about what is it that you really need to do to pass a PCI penetration test, because that's what it's all about. We've talked about the new requirements. We've talked about the common types of vulnerabilities that we see that trip people up. So, I don't mean to hammer this, but it's just really important. You need to ensure the accuracy of your assessment scope. Again, you need to do this as the entity being assessed. You need to clearly understand all of your cardholder data flows, what your cardholder data environment looks like, how it is segmented, and have that all documented. And that's now explicitly required in the standard, as I cited, I believe on page 10 of the 3.0 version, of the specific things you need to document concerning that. It's required for your assessment, but it's also required for your pen test, so your pen test is testing your appropriate scope. Patch. You've got to patch everything, period. It doesn't mean not the packages on the Linux servers that are kind of a hassle or you can't bring down because they have your most important database and your clustering isn't really working that well this year. It's every single application, package, operating system, piece of firmware that's in your assessment scope you need to patch. Of course, there's some criteria for the patch management concerning, risk-based approaches to up to 3 months delay. But for a penetration test, if we come in and we root you because you're behind on patches, then you're going to fail your penetration test. So you need to make sure that you've prepared for your penetration test. Hardening, host hardening, it's the same thing. You need to harden everything. It's required by requirement 2 that you have secure configuration guidelines that define how you securely configure each system. It's not just a paperwork exercise. You actually need to do that. You need to implement these on all systems for all system types. It goes to the application layer. If you have a CentOS box running SQL, then you need to have database hardening as well as operating system hardening guidelines, both of which are implemented on that system. And you need to validate that before your pen test so that you find it, not the tester, unless you want to go through a cycle of test, fix, test, fix, test, fix, which gets frustrating, especially if you're scheduling your test too close to when your audit is due to be renewed. This is something I see really commonly is inappropriate auditing, IDS. I can't tell you how many times we've tested a managed security provider that will go unnamed, where we'll ask the merchant to provide copies of the IDS alerts from the pen test, only to find, lo and behold, there are none because, oops, sorry, something got turned off 9 months ago, right after your last audit. We can fix it quickly, but of course, no refunds for the fee you've been paying for the last year for this IDS or IPS that somehow got turned off. So you need to make sure that your alerting infrastructure is in place. That's also what the pen test is intended to validate. And lastly, I really see a lot of internal secure software review programs which are really trivially compliant, and they're just really going through the motions, and they're hoping that when they get the third party to do the production web app test, they'll find everything for them, and they'll fix it, and they'll get through their audit and be done with it. It can be very frustrating if that's happening right when your audit is about to expire and needs renewed. The bottom line is if you're performing your internal secure code reviews throughout the course of the year and you haven't had a single finding in the last 12 months since your last assessment, then I can almost guarantee that when a third party comes in and provides a legitimate web app test, they're going to have findings. And that means that your internal process is not effective. And so you really need to make sure that you're performing that appropriately. And you need to make sure your testing criteria evolves with best practices. The 6.5.1 through 6.5.10 requirements, the standard even says, these are best practices as of now, but it's your responsibility to evolve with best practices. That goes internally and externally. So I guess at this point I'd like to ask if anyone has any questions. There is a question or chat feature of the GoToWebinar software that you're welcome to provide any feedback or questions that you have for us. But otherwise, I believe we've covered everything that we had in today's webinar. Okay, so one of the questions we have here is concerning how do I understand what specific findings the third-party tester had in a web application test report that need to be remediated? And that's a good question because, as we discussed earlier, the items that are in requirement 6.5 are, in most cases, categories of vulnerabilities. So like much of the PCI-DSS, there's some level of subjectiveness that comes into play here. But what the intent is that you would understand what these categories are and can appropriately map the specific vulnerability that was found to the category that is listed in 6.5 and determine if it actually presents a threat that needs to be remediated. And in some cases, there could be an issue where the finding, a specific finding might fall within that category, but it's not actually something that needs to be remediated because of the business use or the actual component of the application. You know, for example, you might be sending non-sensitive parts of the application over an unencrypted channel, or a common issue would be something like caching, which we didn't talk about it, but one of the common findings is concerning authentication is having cacheable pages that might have sensitive data. And so the generic recommendation is to implement something like Pragma no cache in every page so that data can't be cached. Well, if the data on the pages that do not have that particular control implemented is all static data that you actually want users to cache so that their end user experience is faster because it's static data, images, etc., then that would be appropriate. And this is something that your secure code team needs to be able to understand, first of all, because it's their responsibility to do this testing internally, and then they need to be able to communicate that to the QSA. So as a QSA, I'd say, okay, guy that did the web app testing, he found this issue where you're allowing web pages to be cached, which could be a leakage of sensitive information. Yeah, are you going to fix it? No? Okay, explain to me why. And if I get that answer and it makes sense, then I'm going to say that's a reasonably meets the intent of the standard, and that's appropriate. But it really also is something that your tester should be able to clearly communicate to you as well. So again, we talk about some of these new requirements in 3.0. They're intended to ensure that the tests are legitimate, and you can use to screen the legitimacy of your potential testers. They need to be able to clearly tell you which of their findings would map to one of these requirements in PCI and need to be fixed. And if they can't do that, then you've got a problem. If your secure code review team doesn't understand them, you've also got a problem, but that's independent of the third party that performs the testing for you. So that is important to make sure. So let me see here. What other questions do we have? Let's see. So people have some question about scoping and what the implications are for systems that need to be brought into the assessment scope, even if they don't necessarily have cardholder data and they're not in the cardholder data environment, and what the implications of that are. We touched on that briefly. So the PCI-DSS applies to what they say all system components, and that means anything in the assessment scope. However, there are a few requirements within the DSS that explicitly state that they apply to the cardholder data environment. So the requirements that state explicitly that they only apply to the cardholder data environment, those requirements do not need to be implemented on the in-scope systems that are not in the CDE. I think the most obvious example there is file integrity monitoring. File integrity monitoring is file change detection technology, Tripwire being a classic example, but of course they're not, you're not required to use any particular vendor for this strategy. But that can be somewhat tedious to implement and make sure that your signal-to-noise ratio as far as file change detection is tuned appropriately. And so they require it for the CDE. That requirement, though, is not required for your in-scope systems. But by and large, everything else is going to apply to the in-scope systems. The host hardening, the patch management, the antivirus, the log management, your testing, your vulnerability scanning. So that's the implications of if something's in the assessment scope. Basically, it's treated as being a system which is trusted to connect into your CDE, but lives on an untrusted network. And for that reason, the requirements apply to make sure that it is able to operate effectively as a bastion host on a dirty network or untrusted network and not be compromised. So, that's the issue there. And one other piece, I mentioned that it's systems that are either connected to the CDE or in scope, or which impact the security posture. In a few cases, you might find systems that might impact the security posture of the CDE but aren't directly connected to it. A most common example would be your physical access control systems. Usually runs on some server that you assign specific badges, have access to data centers and things of this nature. That's probably going to just be on your LAN somewhere, not need any connectivity to your CDE systems. The fact is, if that server gets compromised and I can issue myself badges or even do something concerning your HVAC or who knows whatever else, that's going to impact the security posture of your cardholder data environment. So that system, for example, would be in the assessment scope by virtue of that measure. So I had a question about some different segmentation strategies as well, and the question is what are appropriate segmentation strategies? And the question is, it varies broadly, but it's something that is up to you as a merchant to try to implement, or service provider define and get the CDE to sign off on. It's most commonly ACLs. You can use things like two-factor authentication in some cases, some types of VPNs. In some cases, you can get creative, but you need to make sure your assessor signs off on it. So let's see. I have a question here concerning the card brands, concerning Discover, for example. Discover, Amex, JCB, all of the card brands, the major card brands, are involved with the Security Standards Council, and so it does apply technically regardless if you process 1 card or 1 million cards a day. So regardless of if you only accept specific card brands, you still scope does apply to you. As far as tools, we're a bit out of time here, but someone asked about tools. We like Metasploit Pro. That's what we've been using for the last couple of years. We've used Core Impact through the years. We prefer Metasploit Pro now as our core tool set, but I want to implore that it's really important that you use a broad range of tools and that your tester is scenario specific. James was talking about WordPress. He uses Burp Pro as his primary web app testing tool, but when he's doing WordPress components, he has specific WordPress testing tools that he would use to augment and provide a best practice test. So that is very important to make sure it's not a one-size-fits-all scenario. So we need to wrap up here. I will let you know that the presentation will be available afterwards on our website. Here's our information in order to download the copy of the presentation, or if you have any follow-up questions, you're welcome to send them to us through those channels. Thank you so much for attending. We appreciate your time today.
Thanks, everyone.